Hi students, very good morning to all of you. I hope everyone are fine. Good. Till yesterday we have discussed a lot of things that distance, displacement, speed, velocity, acceleration, etc. And we have even seen that the types of acceleration, that positive acceleration, negative acceleration and the zero acceleration, right? In this video, now we are going to discuss about the equations of uniform accelerated motion. What do you mean by uniform accelerated motion? Let us see first. Uniform accelerated motion means if any object start from the rest or else while it is moving with some initial velocity, uniform accelerated motion we are talking about. So if an object, let us take an example of a train. Okay, it is starting at the station A and it is moving with a continuous velocity. Okay, it is moving with some velocity and it is reaching the station B. It is reaching the station B. While it is started from rest from station A, it used to have, that means it used to increase its velocity still more. It used to increase its velocity still more. Continuously it used to increase its velocity. And while it is approaching the station B, it has to come to rest at the station B, right? Then it is going to decrease its velocity. That means it can't apply the sudden brake, right? That means there is sudden change in the velocity doesn't take place. That means whenever it is going to increase its speed, if you observe, it used to follow that there will be a equal speeds in the equal intervals of time. Equal speeds in the equal intervals of time. Then we can say that it is used to have uniform acceleration. Uniform acceleration. Okay, that means whenever the velocity is going to be increased, whenever the velocity is going to be increased or going to be decreased uniformly, decreased uniformly, then that can be considered as uniform acceleration. Then the object used to possess the uniform accelerated motion. Then how can we explain about the non-uniform acceleration? Let us take the example of a bus. While the bus is moving on a straight road, why maybe we are thinking that okay, it is going to increase its velocity, but while it is going to increase its velocity, somewhere it used to get brakes, and then somewhere it used to reduce its speed, and somewhere it used to stop for a longer time, and somewhere it used to go so fast. That means there will be a lot of differences in the change in the velocity. See, suppose this is the total time and from the rest onwards it started. From the rest onwards it starts. Then it used to increase its velocity. And after some time, after traveling to some distance, after traveling to some extent, what it used to have? It used to change its speed. Okay, it used to change its speed or velocity, right? And after some time it comes to rest. That means it used to apply the brakes. That means there will be a lot of changes in velocity. There is no continuous of either increase in the velocity or continuation of decrease in the velocity. And that means it used to possess the non-uniform motion. So here these accelerated equation, uniform accelerated motion equations, we are not going to consider this non-uniform motion at all. We are not going to consider the non-uniform motion. So today we are going to consider for the equations of. So what are we going to consider for? Equations of uniform accelerated motion. Uniform accelerated motion. That means using the, while we are going to derive these equations of accelerated motion, we are going to find out the relation between initial velocity. U is the initial velocity, okay, and V is the final velocity, and A in the sense it is acceleration, and S is the displacement, and T in the sense time taken. Okay, so using all these 5 terms. All these 5 terms, we are going to solve the equations of uniform accelerated motion. That means suppose if we know a few of the terms in this to find out the next term value. So we use these all the equations to solve some of the problems. Okay, right? So let us see how these equations of motion are going to be considered and how are we going to relate this, and what are the equations of motion we are going to solve for. We are going to solve the equations as v is equals to u plus at. This is the first equation, and the second equation is s is equals to ut plus half at square, and the third equation is v square minus u square is equals to 2as. Now is it clear, children? So now we are going to solve these 3 equations of motion using the terms. These are the 5 terms. And while we are solving this, I will ask you a few questions also. You should be ready to answer, children. Okay, right? Now let's go for the first equations of motion derivation. Let's see the first equations of motion. First equations of motion. Right. Until now, we have seen so many things. We have seen so many things that distance, displacement, speed, velocity and acceleration. That means finally the concept of acceleration we have concluded with. Okay, let us take that concept itself. What do you mean by acceleration? How are you going to define acceleration? Acceleration is equals to change in velocity by time. Change in velocity by time. How are we going to write in a equation format of this? A is equals to change in the velocity. That means there is a change in the velocity from final to the initial. That is v minus u by t. I hope so you are well known about this. How come this equation has been come? Let us see then. How this acceleration has been written as change in the velocity by time taken. Let me demonstrate you this. Suppose an object has been started from the initial position with a velocity as u. Okay, with a velocity as u, and while it is moving with the uniform motion. That means uniform velocity. It used to have uniform velocity. Now that means its velocity is going to be increased. Its velocity is going to be increased. While it is going to be increased velocity. So this increased velocity leads to what? Acceleration. Am I right? You remember, whenever the object used to have the increase in velocity, it used to possess the acceleration, or else decrease in the velocity also. That means in the equal velocities in the equal intervals of time, if it possesses, that will be as uniform acceleration. Okay, so that means it used to have some initial velocity and it has traveled to some distance and reached a particular point over here. Okay, with the velocity as v. Okay, and while it is moving, it is having the increasing velocity. That is what it has acceleration also. Then it has covered some of the displacement called s within the time t. Right? So based on this, we have written this a is equals to v minus u by t. Now, how am I going to solve this a is equals to v minus u by t for the velocity, final velocity? I just want the value of final velocity. How to get this? Let us take a is equals to v minus u by t. So this a can be written as a by 1. Nothing is there, in the sense we can write down 1 in the denominator. So put cross multiplication over here. So a t is equals to v minus u. I hope so you are getting my point, children. Am I so clear to you? Right? So now see here, at is equals to v minus u. Thereby I just want value of final velocity. So just send this minus u that side. I don't want here. So at minus u I sent here. This becomes plus u. So while by the way of representation, we have finished it. Therefore we can write down that v is equals to u plus at. This is my first equations of motion. I have succeeded to complete it. for the final velocity. If I want a final velocity, what I have to know? I should know the initial velocity as well as the acceleration and the time taken. If I know all these three terminology, I will get the final velocity. Right, children? I hope so you are very clear about the first equations of motion. Am I right? So let us go for the second equations of motion, children, now. What is the second equations of motion? S is equals to ut plus half at square, right? So for that, I am going to solve it for now. Here there are two methods to solve this even, children. S is equals to ut plus half at square. One is a normal analytical method and the next one is graphical method also is there. Okay, let us see first of all the analytical method. Just now how we solve the first equations of motion. Now coming to the second equations of motion. Okay. So here, in the second equations of motion, we have taken the concept of acceleration first of all. We have taken the concept of acceleration for the first equations of motion. Okay, then what is going to happen? You have learnt about me before, the average velocity. Before that, before the concept of acceleration, what we have learnt about? We have learnt about the velocity, right? So the velocity is feeling very bad. Velocity is feeling very bad. You are not going to consider me at all. So let us consider that velocity for this second equations of motion, then we can understand very clearly. Okay, so while we are going to consider for the velocity, here there are two velocities. These two velocities that you and we are fighting with each other. Then what will we do? Okay, we will take a deal in between them by taking out the average velocity. That will give a better idea for you, right? So let us see. Let us take average velocity. How are we going to find out average velocity? What is the value for it? U plus V by 2 is the average velocity, right? Am I right or not? Average velocity. And we know that, we know another thing in general, that means average in the sense sum of the components by number of components. This is a mathematical expression. This is a mathematical expression. So I am taking this as the first equation of mine. Now I am just writing this average velocity again in terms of another one. See here, average velocity is equals to displacement by time taken, children. Displacement, right? Displacement by time, in the sense what it is? S by t. Got it now? So average velocity is S by t. So this is my second equations of motion. I got for the average velocity equation 1 and equation 2. Means for the average velocity itself, I have two values. Okay, I hope so in your mathematics you know about the transitive property. If suppose A is equals to B, then A equal to C, we can equate these to B equal to C, we can say. Am I right? That is a transitive method in your mathematics, right? So I am taking with the help of that example. Can I equate these two then? Okay, U plus V by 2 is equals to S by T. Can I write? Okay, let's write. U plus V by 2 is equals to S by T. From where? Since from first and second equations. Equations 1 and 2. Okay, I am equating these two because these are the two values for the average velocity. Average velocity is U plus V by 2 and average velocity is S by T. So that's what I am equating these two now. Okay, let's follow our method. While we are going to solve this, here velocity is feeling very bad and these two people are fighting with each other. I will stay like that. That means final velocity and the initial velocity are fighting with each other. That's what I'm doing, you know. Initial velocity it stayed from starting, right? So I will support the first initial velocity. That's what I'm going to replace this final velocity with a value from the equation 1. From first equations of motion. From first equation of motion, we know that, what we know? V is equals to U plus AT, we know. V is equals to U plus AT, we know. Now, see, whenever it is V is equals to U plus AT, substitute this. Now, substitute this value. Substitute. Let us take this as a third equation. Substitute in equation 3. Now, U, I am not changing the value of U as it is, plus. Now in place of v, excuse me, in place of v, you just replace u plus at. Then by 2, I'm not disturbing anything, I'm just keeping as it is everyone, by s by t. Okay, now solve it. 2u plus at is equals to, 2u by 8 plus at by 2 is equals to s by t. Now put a cross multiplication. 2u plus at into t is equals to 2s. But what I want here, only I just want a value of s only. So I will send this multiplicated to this side. So I used to get that s is equals to, okay, 2 I am sending this side, that becomes 1 by 2 now. Now this is 2u plus at into t. Now solve it clearly. Half, this is 2ut plus at square. Now this is the value of s, right? So half into, I am just multiplying this half to everything. Half into 2u plus half into at square. Now I will get cancellation for s is equals to, right, 1 by 2 into 2. Now s is equals to, finally I got as u plus half at square. This is my second equations of motion. This is my second equations of motion. I hope you are very clear about this concept now, children. I am very clear to you. I have taken the help of the first equations of motion, that is v is equals to u plus at, and I have substituted this value in this equation in the place of v, and then I have solved for it. I hope so. You all well known about the mathematical algebraic expression solutions, right? So in that format I have solved for s. That means yes, I have made a subject of the formula. Am I pretty clear to you, children? I hope so. Okay, let us go for the next equations of motion, that is third equations of motion. What do you mean by the third equations of motion here? What is the third equations of motion, you remember or not? Third equations of motion. Okay, here also we are taking the same concept as, that is average velocity is equals to, yes. So whenever we are talking about the average velocity is equals to displacement by time taken. Of course, we know this very well. Now, if we take the same concept, what are we going to get? Maybe we are going to get a confusion over there. Okay, let us see what is going to happen. I will take average velocity is equals to displacement by time. Displacement by time. This concept I am taking because there I have taken two things, right? That's what displacement is feeling very bad. Okay, to solve me you have taken two equations help. Okay, so that's what I am doing, you know. Average velocity is equals to displacement by time taken. Now let me do the cross multiplication over here. So displacement, this is by 1. Okay, let me do cross multiplication. So displacement is equals to average velocity into time taken, Now what is displacement symbol? Yes, average velocity is, okay, already we have taken this relation, right? So average velocity we will take the relation as u plus v by 2 over here. U plus v by 2. Already I have shown you in the previous equations of motion, equations of motion 2. In that I have already shown you that average velocity is u plus v by 2. So that equation of motion I am taking here, s is equals to u plus v by 2. Very good. Now into time. Okay, time in the sense here t, I have written time. Okay, now time is feeling very bad here. Time is feeling very bad. You are using me in all the equations of motion. In the first equations of motion, you have used me, that change in velocity by time taken. And the second equations of motion also, you have used that average velocity is equal to displacement by time taken. And here third equations of motion. Now in this equation also, you are using me. That's what it is feeling very bad, and it won't rest, it seems. It won't rest, it seems. We will let us give the rest for time here. So what will we do? We will take again the help of the first equation of motion. Okay, see here, from first equation of motion, what I am taking, I am going to solve for time, children. I am going to solve for time. That is v is equals to u plus at, right? So what I am going to do, v minus u, I am sending this u that side. V minus u is equals to at. I want the value of t. I want the value of t. So t is equals to v minus u by a. Now I am going to take my equation and substitute in place of time. Then all the time will be in terms of final velocity, initial velocity, and then acceleration only, right? So that will give a better relief for the time, right? So let us substitute then. So S is equals to u plus v by 2 into v minus u by a, since from equation 1. Children, don't get confused. Equation 1 and first equation of motion. So don't get confused. I am writing the numbers, that's why. So from equation 1, I have substituted the value of time as v minus u by a. Now, if there are two fractions we are going to multiply for. How are we going to multiply for? The numerators we are going to multiply for. Let us see. So it is in the form of, can we write this in the form of v plus u? Means a plus b or b plus a, and both are same, right? Okay. So into, I am multiplying the numerators simply first of all. By 2 into a, 2a. Now S is equals to, observe these two conditions. These are in the form of a plus b into a minus b. A plus b into a minus b, in the sense it will be given as a square minus b square, right? This is the formula for a plus b into a minus b. So write down, this is v square minus u square. I am writing this v plus u into v minus u in the form of v square minus u square with the help of this formula. Now by 2a, I didn't disturb. Now put 1 and apply cross multiplication. Then we will get it. So let us see, v square minus u square is equals to 2a. Yes, while we are doing the cross multiplication, we are getting the value. So finally, we reached our third equations of motion. Okay, we are getting as third equations of motion. We have derived all the three equations of motion, children. I hope so you are very clear about this concept. Am I right? Okay, I told you that the second equations of motion we will solve using the graphical method, right? So let us see the graphical method of solving the second equations of motion. Let me explain that even. Graphical method to solve the second equations of motion. Let us see. Suppose in the graph we are mentioning that the object, now this is the origin, right? This is the origin. Okay, so the object is starting, this is the velocity time graph, children. This is the velocity time graph. I am taking the velocity time graph. Time I am considering at this condition, and I am considering the velocity over here. Velocity I am considering here. That means in this direction. Now time is in this direction. Now let's see. Object is moving with, it is not moving with zero velocity, children. It is just moving with some velocity u. We have already assumed that, right? And then it is moving with the uniform acceleration. Uniform acceleration in the sense it is going to have a straight line. It is going to have a straight line, and it is reached the final velocity v finally. Okay, now let us drop a perpendicular line from here. Let us drop a perpendicular line over here. Okay, now this is the perpendicular line I have drawn. Now let us drop up another perpendicular line from u to the dropped line. Already we have dropped one of the perpendicular from this point of v, right, to the x-axis, So let's drop for it. Why am I doing this? I am going to find out the areas of it. If I find out the areas, I can solve the sum easily. So what I am going to do now, I am going to solve it for, right? So velocity time, using the velocity time graph, I am going to solve it for second equations of motion, that is S is equals to ut plus half at square. Whether I am going to get this ut plus half at square or not, I am going to see. Now what is this value, children? This value is u. And what is this total value? This total value is v. Okay. And then what is this value then? Suppose this is totally v and this is u. Right? This is u. Then what it becomes? This is v minus u. Am I right or not? V minus u. And now what is this? What is this length then? T. Time taken t. Now I have a rectangle and the triangle. I have a rectangle as well as a triangle over here. Now let us see the areas of these two triangles. Now let us imagine O, A, B, C, D. Okay, I am mentioning this O, A, B, C, D. Let me drop these here. O, A, see this O, A, B, C, and then the point D over here. Okay, now let me write down all the values of it. This is u and this is t. Okay, and this is v minus u, and of course this is t, right? This is u, leave it, right? Now I have mentioned all the values except this slant line, except this hypotenuse line. I have mentioned all the values of here. Now find out the area of the figure 1. This is figure 2. Okay, now see here. To get this means, while we are finding out the area of this total picture, we are going to get the, that means the area of velocity time graph gives us the displacement. Velocity of the, area of velocity time graph gives displacement. In the next class, we will discuss about how are we going to drop the graphs and how are we going to get the areas of this velocity time graphs or distance time graphs, etc. Okay, then you will get a very clear idea about it. Now let us see. Area of the velocity time graph, that means that is what displacement. Now displacement is equals to, we can simply say that displacement is equals to area of figure 1 plus area of figure 2. What is this first figure? It is a rectangle. So area of OABC plus area of triangle CBD. Clear? Area of triangle CBD. Now area of rectangle. Rectangle. What is the area of rectangle, children? Area of rectangle in the sense length into breadth, right? So that is length. Let us take the length as OA. OA into this is length. Okay. Now let us take breadth. Breadth is OC. OC breadth. Okay. This is length into breadth. So this is my area of rectangle. Now half. Area of triangle is half into base into height, right? So what is my base over here? Base into height I should write. So half into base into height. This is my formula. I am just writing on the top to make you understand. So base. What is the base over here? T is the base. T is the base. And height is what? V minus U is the height. V minus U is the height. Now, what is this? Okay, I have mentioned here OA and B. Here I have mentioned with T and all. Okay, let me substitute this. Half into base is BC and then this is what? DB. Okay. Okay, sorry for the corrections. Okay. Now OA. OA is what? T into breadth. OC is what? U plus half into BC is T. Already we have seen that, right? So DB is V minus U. Now T into U. I am just writing as UT plus half into T into, what do you mean by V minus U from first equations of motion? From first equations of motion, we know that V minus U is T. So V minus U is equals to AT. So V minus U is equals to AT, since v minus u is equals to at. You just simply write down like this, then you can understand. So that is ut plus half t into at, that is at square. So finally the displacement is s, right? So s is equals to ut plus half at square. This is our second equations of motion by the graphical method. I hope so it is very clear to you all children. Am I right? Thank you so much. And just practice all these three equations of motion, children. All these three equations of motion very clearly. Okay. Take your book. Don't leave it over here only. Just practice well. Then you will get everything. Thank you so much, children. Take care. Bye.